Okay, this is the P2 paper from June 2021. This is question number 5. And if I scroll it down, you can see that it's an integration question. We're going to be doing some work on the trapezium rule first of all. Then we're going to be finding an integral. And then we're going to find an area under a curve, or an approximation to an area under a curve. Okay, so let's have a look at the first part again. Make a start. It says we've got this graph, tells me the table is giving me all the values here, and says, can I find to 2 decimal places an estimate for the area bounded by the curve and the line, and x equals 2, x equals 4. So what that in effect means is, can I use the trapezium rule to work out that area? Well, absolutely I can. What I need to do first of all is just count up how many different values I've got here. So I'm going to call this y0, y1, y2, y3, y4, y5, and y6. Okay, so if I'm trying to work out the estimate of this area, then it's going to be, using the trapezium rule, I'm going to say the estimate is equal to d over 2. Now d is going to be the difference between all of those each time, so in this case 0.25, that's my d. d over 2, and then it's the first one and the last one, so y0 plus y6, and then 2 lots of everything else, so in this case y1 up to y5, 3, 4, 5. So that's a trapezium rule. All I need to do is to substitute in all my values here, so it's 0.25 over 2, and then it's going to be 5.453 plus 5, and then 2 lots of all of the other ones. So 7.764 plus. Just be careful when you're putting these values in, obviously. Trapezium rule should be a nice place to get some marks, but we do need to just be careful. So I need to stop talking so I can concentrate on what I'm doing here. 964, 9367, and 7626. Scoot that all over a bit. So it doesn't really matter what I've got written down there. What it is absolutely vital is obviously when I now plug all these values into the calculator that I get the correct answer, which is 12.33. Go back and just check, it does say to 2 decimal places there, so 2 decimal places. Then part B says, we actually know the equation of the curve now, it's x to the 3 over 2 minus 3x plus 9. Can we just find the integral of that? Well, yeah, that should be absolutely straightforward. Part B, if I want to find the integral of x to the 3 over 2 minus 3x plus 9 dx, this should cause me no problems at all. Remember the rule, add 1 onto the power, divide by the new power. So adding 1 on to 3 over 2 makes 5 over 2. Dividing by 5 over 2 is the same as timesing by 2 over 5. Try and help yourself out with a few shortcuts. Adding 1 onto the power makes squared divided by 2. And then obviously when we get to a constant, that just becomes plus 9x here. Please don't forget your plus c. Nothing to simplify there, so let's just go back and check. It said, find the integral. Brilliant, 3 marks for that. That's a nice, easy 3 marks on that part there. And then part C says, use the answers to part A and B to find to 1 decimal place an estimate for the region R. So what we've actually done now is the first answer would have given me an approximation for that area when I was using the trapezium rule. The second answer is going to give me an approximate, no it's not, it's going to give me the exact value for the area under the curve. So if I do one of them minus the other one, that will give me the answer for the area. So for part C, I have to start off by actually working out that second area, which is saying that it's the integral between 4 and 2.5 of my function there. But I've already done the integral, so it's actually 2/5 x to the 5 over 2 minus 3 x squared over 2 plus 9x. It's that between the values 4 and 2.5. So let's get a numerical value for that by subbing that in. So it means putting 4 in and then taking away putting 2.5 in. If we put 4 in, it works out to be 24.8. If we put 2.5 in, it works out to be 17.077. So in other words, it works out to be 7.722. I'm only going to be doing it to 2 decimal places, so it doesn't matter how accurate I make this one. The area R then that we're interested in is going to be the area generated from the trapezium rule minus this area here. And then to account for any inaccuracies, they've just said they only want it to 1 decimal place there, so it works out to be equal to 4.6. So, nice straightforward question there. Hopefully that will make sense to you.